Hey guys, I have here a Supermicro CSE-846 4U server chassis. With a few small modifications, we're going to convert this to a JBOD disk shelf and pack over 700 terabytes of hard drives inside. That's a massive amount of storage and is going to more than double what's in my rack currently. In today's video, we'll go over the choice of components, the build process, some cost calculations, and much more. So let's take a look at what we got. As I said, this is the CSE-846 server chassis. It's got 24 front-facing bays. It did come with all of the caddies. It also came with the inner and outer rails, so it's got a full rail kit. We got 3 fans. Taking a look inside, the 3 fans go in the center fan wall here. There's also space for 2 more fans in the rear of the case. We can fit a standard ATX motherboard. There are 2 power supplies on the left side here. It did not come with power supplies. That's not a problem. I have plenty of spares. It did come with a SAS backplane as well. On the right side, we have an SFF8087 SAS input, and then we have 2 more SFF8087s there in the center, which we can use for stacking additional expanders. And we've got a number of connections coming off of the power supply PDU here. So the idea is to build out this case with as few modifications as possible, get those hard drives installed. That way, if later on down the road I decide I want to do something different, I haven't completely ruined the case. I can simply pull out those drives and put the new build inside. These are the hard drives I'll be installing in that server, at least some of them. These are all 18 terabyte SAS drives. They are white label. See, there's a white label there on the drive and it says OS, which stands for off spec. So these drives were originally Seagate Exos drives. So these are drives that were rejected or returned for whatever reason. I'm told it's mostly cosmetic issues like dings, scratches, or bad firmware on the PCB, things like that. And I'm told these did originate directly from Seagate. But anyway, I purchased all of these drives from the Digital Spaceport store. He stocks the 14, 16, and 18 terabyte. He has SAS and SATA. I was a little hesitant at first, so my first order was 2 drives, which I do have a video on this channel about if you're interested in checking out. And I liked what I got, so I purchased a couple more and those worked great as well. So this last order, I have approximately 2 cases worth of these drives. The plan here is I would like to fit 16 drives on the inside of this case. Now in some of my previous videos, I took a 3U chassis and I put an ATX power supply in. But since this has a little bit more space, the power supplies are actually mounted vertically along the side. Compared to looking at the power supply bay for the 3U chassis, you can see it's actually about half of the width there. So I will definitely plan to use the original power supply in this chassis. And I think with all of the leads this power supply has, I can get the 12 volts and 5 volts I need off of these leads for the 16 drives in here. So I can temporarily remove the fan shield. I don't need this little chassis switch here, and I don't need this front LED button cable. And for connecting these drives, I selected the Supermicro SAS743TQ backplane. This backplane supports up to 8 SATA or SAS 3.5-inch discs. It's powered by a pair of standard Molex power connectors, and you have 8 SATA connector outputs, which will go back to your SAS Expander or your SAS controller. Now, even though these are standard SATA connectors here, these do need to go to a controller that supports SAS drives. You cannot connect this directly to your motherboard or something like that. Another choice I did consider is this option here. This is from an HP ML10 G7. It is part number 466509. And this is a 4 SAS or SATA 3.5-inch drive backplane. Again, it's powered by 2 standard Molex connectors, but the difference here is we have a single SFF8087 output, which makes cabling a little bit better going from this backplane back to your SAS controller or your SAS Expander. Another huge advantage to this backplane is these sell for $21 on eBay. I purchased 4 of them. So $21 gets an 8 drive backplane, whereas this option sells for $29. So not only is this one more expensive, but you have to buy 2 times the backplanes for the same amount of drives. So next we need to figure out how to mount our hard drives so we can actually connect them to this backplane. And for doing that, I picked up 2 pieces of aluminum at Lowe's. I have this aluminum U-channel here. This is 1/16 inch in thickness and it is 1/2 inch in width. So a 4-foot piece of this was only $8, seemed like a pretty good price to me. And then I also picked up this, 1/2 inch by 1/16 thick aluminum as well. And what that results in is a configuration like you see here. So we have 8 of our SAS hard drives, and you can see I have 2 U-channel pieces on the bottom. And then I have that 1 thin piece going across the top. So all I did was line up these hard drives so that they fit onto this backplane, and then marked each place I need to drill a hole. Now in the past there was a concern of vibrations, because these hard drives are not isolated from one another. And I did attempt to resolve that in the original design. I ended up using some of these rubber grommets, but I really feel like having them held together as one solid mass like this in a more rigid design actually reduces the vibrations, whereas having them kind of sitting on these rubber grommets allows them to vibrate a bit freely, if that makes sense. And there's actually an interesting post written on 45drives.com. They actually screwed some hard drives to a thick piece of granite and measured the vibrations attached to the granite versus suspended. And these are pretty much standard case screws I used. I made sure to select some that had these serrated grooves in here. Those serrated grooves will bite down into this aluminum when you tighten them down and just prevent them from backing back out. So here's just a closer look at that design. And on the bottom you can see where all the case screws are holding the drives into place. So then we just need to carefully line up our backplane here. All right, and they're all connected. 16 drives ready to go. So the plan is to simply set one block of drives on each side of this case here, and the second block will go on the other side. Now, there is one slight concern with this layout, and that is that, the fans will be in the fan wall located here, and will be blowing air in this direction over the drives. And it would have been preferable to turn these drives 90 degrees such that the fan air is blowing through the drives rather than, kind of like directly into the front here. And this is the only way I could fit these drives in, giving them enough room for the SATA and power connections on each side, and to fit in the SAS Expander we have to add, which will sit over here. And I'm thinking the amount of air that this fan wall will be moving will still keep these drives cool even though it's not blowing through them. So I will certainly be monitoring these drives just to make sure those temperatures don't get too high. And to mount these drive blocks into place, I simply drilled a series of holes into the bottom of the case and epoxied these threaded studs into place. Now this works because this case bottom is actually 2 layers of metal. So I only drilled through the first layer. I did not puncture the entire way through the case. Now we have our SFF8087 on the inside of this case all the way in the front there. And we need to have some sort of input in the back of the enclosure. So to make that run, I'll be using this cable here. And this is a bracket with a dual SFF8088 connection. And you have 2 lengthy cables, I don't know, they're about 3 feet long, which go back to some SFF8087 connectors. So I'm simply going to install that in the farthest most bay here. So I just secured that cable in place there with an adhesive pad. And I looped the excess around in the bottom of the enclosure down there where it won't get in the way of the fans. And I have the input on the right and the output is on the left there in case I want to daisy chain another chassis. And that leaves us with one SFF8087 connector, which we'll use to connect all of the internal drives. This is the SAS Expander I will be using. This is a Lenovo 16-port 03X3834. So we have our 2 ports on the top where you would put your SAS in. Then you have a SAS out where you can daisy chain additional cards together. And we have our 4 ports here, which will go to drives 0 through 3, 4 through 7, 8 through 11, and 12 through 15. And I imagine you could probably connect an additional 4 drives to the top here if you don't plan on daisy chaining these cards together. Now this card is designed to go into an X8 slot, a PCIe X8 slot. But this doesn't actually need to communicate with the computer in any way. It simply needs to obtain power from this PCIe slot. So because there's no motherboard in this case, we'll need a way to provide power to this expander. And to accomplish that, I'll be using one of these PCIe riser boards. This was really designed for people who are GPU mining. So we will put this card in like so. And then we have a standard 6-pin input to provide 12 volts power to this card. And we're going to sit that in like so. The rear of the card will rest on the bottom of the chassis, and I'm going to cut a small piece of aluminum, and that gives the setup you see here. And that card is definitely held in place nicely. You can see that little bracket I made there. So yeah, that'll work perfectly. So now we're ready to discuss how we're going to get power to all of these drives. So the plan will be to tap into this 24-port motherboard connector. But before we do that, we first need to understand the specifications of the PDU or the power distribution unit. And that card I'm referring to is right here. This is model number PDB-PT846-8824. Alright, so here's the same power distribution module on the Supermicro website. Unfortunately, it doesn't give any specifications in terms of power. It just sort of says what systems it's compatible with and what chassis it works in. Doesn't give any voltage or ampere ratings. However, I did find the specification sheet for the 846E1-R900B, and in the parts list it includes a 900 watt power supply, and it includes the power supply backplane, the same model that we have here. And further up, it does give a rating of the power supply and distributor of 50 amps at 5 volts and 75 amps at 12 volts. So the 5 volts is what I was concerned about, and 50 amps is more than plenty for 40 drives. So if we look down in here at how Supermicro does this, there's a total of 6 Molex connectors on this backplane. Those Molex connectors are powered by 3 lines coming off the power supply. Those are done with 16 gauge wire. So Supermicro made sure to put a little bit beefier wire in there. So most of the wiring coming to this ATX 24-pin connector here is actually 18 gauge. The only exception seems to be these orange leads, which are going to be the 3.3 volts. So you might be able to get away with 8 drives on an 18 gauge, considering the distance is fairly short here, but I don't want to chance it. So I will be running 4 runs here. So that means we'll need 4 5-volt pins, 4 12-volt pins, and 8 ground pins for these hard drives, a 12-volt and a ground for this expansion card. Looking at the pin information for the ATX 24-pin connector, we have 3 5-volts, we have a total of 5 5-volt connections, but we only have 2 12-volt connections. So we are short 3 12-volt connections. So to make up for the extra lack of 12-volt connections, we'll be using this 8-pin CPU connection. Now, this is the point where people are going to be like, no thanks, because this is the DIY part of power distribution. So here's the cable harness I made to power these drives. I did not want to cut the wires off this connector because these PDU backplanes are actually very expensive. This particular one sells for about 200 bucks on eBay if you were to buy that part separately. It's a ridiculous price, honestly. So I went on Amazon and I purchased a 24-pin extension and an 8-pin CPU extension. They're very, very cheap, and I just cut off the ends of those. That way I have a female connector of each to connect to the wires from the power supply. So I've got my 4 Molex connectors. I pulled these off of scrap power supplies. I've got all kinds of wires, just scrap wires in a bin. And then I have a 6-pin GPU connector. I also pulled the same way from some scrap power supplies. From the 24-pin ATX connector, you can see I have 4 red wires, which go back to the 5-volt leads. I have 2 yellow wires, which go back to the 12-volt leads, and then I have 6 black wires, which go back to the ground lead. I have an extra pair of 5-volt wires, which I didn't want to damage, so I simply capped them off in case I need them later. And then you'll see here, I have a green and a black wire spliced together. Pin number 16 is the PS on, or power supply on pin. So all you need to do is jump that pin to any of the ground pins, and that will automatically turn your power supply on. So then I use the CPU connector to make up for the remaining 12-volt leads I need. So 2 of those 12-volt leads and 2 grounds go to the remaining Molex connectors. And the remaining 2 12-volts and 2 grounds are going off to the 6-pin connector. Now, in building something like this, it's very, very important to understand the electrical characteristics of your cabling, your connectors, your drives. For example, these drives probably idle around 7 to 8 watts. Which is really a little bit more than half of an amp. So 8 drives is only 4 amps, divided by 2 connectors is only 2 amps on each of these Molex connectors. And that's divided further between the 5 volts and the 12 volts. So I might only see 1 amp on each of these pins. But the problem comes is when all these drives go to spin up, there's an inrush of current, which can easily be 3 to 4 times that. Now, one advantage of using these backplanes here is these backplanes will actually do staggered spin up, as opposed to just connecting directly to the drives. It would just start them all at once and pound your power supply. These backplanes will actually stagger start up these drives so that they're not all starting at the same time. Additionally, a key piece of information is that the reason there are multiple Molex connectors is really the power limit rating of the Molex connector itself, not necessarily the wire that's going to the Molex connector. And this looks much less intimidating now that I've tidied up those wires nicely. For the data connections from the backplane to the SAS Expander, I have these 1.6 foot breakout cables. On one end, we have an SFF 8087. On the other end, we have 4 SATA connections. They will connect to the backplane like so, and we'll connect our power. This is a pretty tight fit with these SAS cables. I had purposely purchased these smaller length cables so I wouldn't have like an extra 2 or 3 feet of cable wound up in here. And this one here going to the far side of the backplane is like just the right length here. We need to connect our SAS Expander to our front backplane. And I just have a simple SFF8087 cable. It's got the same connector on both ends here. Nothing too exciting for the cooling. I have the original fan wall and the original 3 fans. These are SunAce fans. They're fairly standard in Supermicro enclosures. So I bought this little controller board I'll be using. This is just a PWM controller. It'll work with any PWM fan that is a fan that has 4 pins. So I have a standard 6-pin power connector, and then I have 8 fan outputs. And then I have a single knob here. I can adjust the speed with that PWM controller. So I've got the 3 fans put back in the fan wall here. This little controller board comes with an adhesive pad on the bottom, so you can stick it to pretty much any surface. However, this does have a lot of exposed 12-volt pins, and what I don't want to happen is, 2 years down the road, this adhesive to dry up and give out. So what I think I'll do here is just drill 2 holes through this fan caddy. That way I can loop a zip tie around and hold this in place in addition to that adhesive pad. And there is the finished fan wall, ready to slide in place. And that fan wall is held in place with 2 screws located here and here. There is a single Molex connector coming off of this power supply, and I just have a Molex to 6-pin adapter, which should work perfectly for 3 fans. Alright, I'm ready to turn this thing on for the first time. Now, very important, I have double and triple checked every single pin on this wiring harness to make sure they are all reading the correct voltage, because a single wire out of place can easily destroy, $3,000 worth of hard drives. I've double checked every single pin. I am going to turn this on with the fans disconnected first so you can hear the drives start up. I don't know if you can hear that on camera, but that was super cool how it stagger spun up all those drives. It sounded like 1 or 2 at a time as it went through the entire 16 drives. It seems stable around 168. So here go the fans, and this is probably going to be very loud. So at 205 watts, that's approximately 36 watts for all 3 of those fans. And look at that noise and power consumption drop. That's around half RPMs there, and we're down to 180 watts. So the rails that came with this case are very used, and parts of them are bent, and there's like tabs and stuff missing. So the last thing I want to do is have this server accidentally fall off those rails and onto the floor. So I put it on this little bench thing, which coincidentally is the exact height for lining up these rails. So alright, so here it goes, the initial startup. Got my kilowatt meter and a nice beefy power cord. It's pulling around 355 at startup, and we're right around 370 as the front drives begin to come online. It looks like they're all online at this point. Alright, so on the right hand side here I've created a number of empty directories to mount these drives to. So if we do a grep on geoplots 04, and my naming convention for these is the first 2 numbers are the drive shelf number, so this is enclosure number 4. And the second 2 numbers are the drive numbers, so we'll have it 01 through 40. So I've got 40 empty directories, and if I do a df-h plots 04 star, we can see none of them are mounted currently. And we're actually going to do a watch-n, we'll do half a second, should be good. On the left-hand side here, I have a script I use to mount drives. So this is the section for enclosure number 4, and it's pretty much just the UUID of the partition and then the directory it gets mounted in. And I've got all the way down to 40 already partitioned and ready to go. Most of them are actually full already. I've been sitting on these for about a month, so I was going through one by one and partitioning and filling them. Now when I run the script, it will throw errors for enclosures 1 through 3 since those drives are already mounted. So here we go. And here they come. We have drive 6, 7. One by one they're coming online. This is exciting. 30. All right, and it's finished. So if we do our df-h again, you can see all 40 drives, 1 through 40. And like I said, most of them are full already. So, all right guys, so I wrote this little command here to pull back the drive temperatures, just pulling them from SmartCTL. And they are running a little bit hotter than I would like, at least the ones in the back of the enclosure are. So you can see most of them here are in the high 20s or the low 30s, which is perfectly acceptable, nothing wrong with that. But as you get down to the lower drives here, which are the ones in the rear of the enclosure, the hottest drive is running at 44 degrees Celsius. It's really the SAS drives, which is going to be the side the power supply is on. 44 isn't that bad, but it's definitely in the territory of I want to watch and make sure. I think it'll be okay, but if I do end up having a temperature problem, one idea I had was to turn those fans upside down, and that will put the fans more towards the top of the case, which will push air directly over the drives instead of having the air blowing into the front of the drives. I think that's what's really stopping the air movement in that case. But yeah, I'll certainly be keeping an eye on this. All right, 24 hours later, I have 2 small changes I made to help with the temperature in here. First of all, I moved this expansion card 1 slot this direction. So it's now resting on the same point as the SFF8088 bracket, which allowed a little bit extra slack in this cable. Additionally, I tucked all the power cabling down in front of the drives below the fans, actually significantly increased the airflow over these drives. It's incredible how the smallest obstacle can either block airflow or just change the direction it's going in. So I'm getting a lot more warm air out the back of the case now, and I'm hopeful that will help drop the temperatures a couple of degrees. All right, so this has been running for a little over an hour now. You can see it farming. Every time it does a plot lookup, some of the LEDs blink. So it's stabilized around 330 watts of power consumption at the wall, and that comes out to 8 1/4 watts per drive. That includes 40 hard drives, 3 backplanes, 1 SAS Expander, 3 fans, and the efficiency loss of the power supply. I have an 800 watt power supply in there currently. I also have a 1000 watt power supply with an 80+ gold rating, trying to figure out which one of these two is going to be more efficient for the particular load I'm running. All right, let's take a look at what it costs to build something like this. This is a Supermicro CSE-846 4U chassis. I purchased this from Digital Spaceport. I paid $213. That cost included shipping, it included all the caddies and a rail kit. I kind of knew he had one that he might not be using as he built out his rack storage with the NetApp enclosures, so I let him know that I was interested in buying, and he gave me a fantastic price on that, so thanks again. The most expensive part of this build is going to be the hard drives themselves. Now, I mentioned that I did use SAS disks in my build. However, I purchased those disks in about 2 or 3 orders over a period of time, and the price has been changing a lot depending on inventory and sales and whatnot. So I priced this out with the cheapest 18 terabytes he has for sale currently. And I will link to all of these items down in the video description if you're interested in checking them out or purchasing something. So if we take a look at the hard drives that are for sale. So I purchased the 18 terabyte SAS here. They are $205 currently. The cheapest 18 terabytes he has are the white label SATA currently for $198. And at the top here, you can see he does offer 3% and 5% discount codes. I'm currently signed up at the 3% rate. I think it's only $1.99 a month. It's definitely worth doing if you're interested in purchasing any hardware from here. So the price I have here factors in that 5% discount code. At 40 drives comes to $7,524. Next up, we have the Supermicro backplane. I purchased 2 of those at $21 each. The Lenovo SAS Expanders, $31.88. There are a number of listings for these you can actually get much cheaper if you're willing to wait on shipping. There are some that ship out of China that may take a few weeks to get here, but you may pay half the price of this. And there are some that include cables and you won't have to buy cables then. So the SFF8087 breakout cables are $14.99 for a 2-pack. I purchased 2 2-packs or 4 cables total. Our power riser boards for the SAS Expander, $8.99 for a 4-pack. So I only used 1 of those. That's $225 for that power board. These are very, very cheap right now. I think there are a lot of sellers that are trying to unload their inventory as GPU mining is pretty much dead, and there really isn't a whole lot of purpose to them other than the GPU mining they were designed for. So you can pick them up pretty cheap at this point. The SFF8088 external bracket was $24.99. Then we have the aluminum channel from Lowe's and the fan controller. So the total price comes down to $7,901 for 720 terabytes. Now that does not include sales tax or shipping fees. I don't typically include sales tax because that varies from state to state and even locality to locality. The same with shipping, it's going to depend largely on where you are. if you can pick things up locally, and if there are any sales going on. For example, Digital Spaceport had some great sales around Christmas time. For like 2 or 3 weeks, he was offering free shipping. The other thing is the chassis. If you're looking at purchasing one, I would strongly encourage you to shop around. Don't just go on eBay and grab the first one you could find, because they are super expensive. If we look at what's for sale on eBay, the cheapest 24 bay enclosure, where is it? $599 with free shipping. $600. The cheapest 36 bay here, you can see they start at $450 with free shipping, but there are no caddies, and those caddies are quite expensive. So the cheapest one with caddies is $499 plus another $99 shipping. And then the largest one they make in the 4U is the 45 bay enclosure. And the cheapest one is $700 plus 120 is $820 for this chassis. And it does have all of the rear caddies. It looks like it has the expansion card there in the center, but still, that price is borderline ridiculous in my opinion. So if you can find a deal on the cases, that's definitely what will bring the cost of this build down. I would recommend checking Facebook Marketplace is a great place to look, and also Reddit HomeLab Sales. If you can find someone local selling one on HomeLab Sales. And also, this did not include some of the miscellaneous components I pulled from parts bins, such as screws and the Molex connectors. So if we look at the price is $7,901 divided by 720, we're looking at $10.97, $10.98 if you want to round up, per terabyte for storage. That includes the drives and all of this equipment, not just the drives. Less than $11 per terabyte. So that's actually a great price. It's pretty exciting. Alright, so this video turned out way longer than I had expected, but I hope you enjoyed it anyway. Feel free to leave any questions or comments down below. There are some things I know I'll get asked that I can answer right away. Yes, I know there is a 36 and a 45 bay 4U chassis. Yes, I know there is a little JBOD board you can put inside the Supermicros to turn it into a JBOD. Those boards are expensive and it doesn't really benefit me in any way versus what I did here. Yes, I know it would have been significantly easier to buy multiple chassis or the net apps instead of one chassis, but the purpose of this was to pack as many drives into the 4U as I could, and I think I've accomplished that quite well here. Anything else, feel free to ask. Please hit that like button before you go, and thanks for watching.